Hi guys, so when we last left off, we were working on the algebraic proof packet, and so we had talked about that there is a way to prove that something is true 100% of the time. We talked about how vertical angles are true 100% of the time, and we used kind of an informal proof in class to do that. And then we stopped. And so what we're going to do now, before we get into some of the geometry style proofs, we're going to practice with some things you might be a little bit more familiar with. We're going to start with some algebra. So these are the algebraic properties of equality. We're going to start with algebra proofs. And so let me go through some of these that you've seen before. Perhaps. The reflexive property, these are matching by the way, the reflexive property is this one. Just says that the same number equals the same number, like 7 equals 7. That's true all the time. Then we have the next one I'm going to go to is symmetric. You'll notice this is very similar to reflexive. The only difference is which side of the equal sign something's on. If A equals B, then B has to equal A. So it doesn't matter if something's on the left or on the right-hand side. The next one is transitive. If A equals B and B equals C, then A equals C. So notice both A and C equal B. And since they both equaled B, they can equal each other. A equals C. This next one is substitution. There's actually two meanings for substitution. There's meaning number one, you can replace A. If A and B are equal, you can replace B for A in any expression. And then we also use substitution anytime we're combining like terms or we simplify something, we clean it up in an equation, something like that. The rest of these, I'm hoping maybe you can figure out now that we've used up some of these for you. And I want you to kind of take a second and see if you can guess. So for example, this first one, if A and B are equal, then you know, you did this in algebra last year, that you can add any number C to both sides of the equation and it won't change the equation. It'll be equal as long as you do it to both sides. And so we would call that the addition property of equality because we're adding something to both sides of the equation. Right? So take a minute, pause the video and see if you can, now that we have eliminated some of your options, if you can figure out the ones that are left. Okay, so I hope you figured out subtraction is when you subtract any number C from both sides of the equation, just so long as you do it to both sides. Multiplication is when you multiply the same number times both sides. Division is when you divide the same number by both sides of the equation. And then at the very end, I hope you felt familiar with the distributive property where A times B and A times C when A is outside the parentheses. All right, so we're going to now use these properties. These are on your pink sheet that I believe I handed out in class. If not, there are still some, there's some on the green bulletin board if you didn't get one. They're on the back side of your pink sheet and you might want to use that for reference as we go through and do some proofs. So one thing before we test this out, just wanted to differentiate. We've been talking about theorems and postulates, but I'm not sure thus far we've talked about the difference between theorems and postulates. Theorems are things that can be proved. You can write a proof. They're rules that can be proved. And postulates cannot be proved. We just all assume that it's true because there's no way to actually prove it. All right. So it says in example 1, name the property of equality that justifies going from the first statement to the second. So all of your answers, A, B, C, and you try, they are all these properties of equality that we are using for our answers. So here we go. What we're doing is we're looking at the first line, we're looking at the second line, and we're trying to figure out what they did. So like my 6 is the same, my 9 didn't change, but the 4 and the negative 2n, something happened with those. It looks like they took 4n and subtracted 2n and got 2n. So we would say this is combining like terms. They're not subtracting anything from both sides of the equation because they didn't subtract a 2n from the 9. They just added things on the, or subtracted things on the same side of the equal sign. And let's see, combining like terms, that was the second meaning of substitution. So this was substitution, was our answer for that. I'm going to write combined like terms, but you don't have to write that. Since there's two meanings for substitution, I want you to know which one we were using. All right, part B, here we go. We got 3 on the outside of the parentheses. In the second line, 3 is not outside the parentheses. It looks like perhaps they used the distributive property to distribute that 3 to both the x and the 2. It's actually distributive. There we go. Part C, let's look at this one. 3x plus 2x plus 5 equals 10. And then the second line, 5x plus 5 equals 10. Looks like the 5 didn't change and the 10 didn't change, but this 3x and 2x, they put together, they combine like terms again. So again, this is substitution. All right, this U-try is really pretty tricky, so I want to kind of point out to you something that's going on here. So x equals 5 is one piece of information that we have. We also have 2x plus 3. Notice that in our second statement we have 2 times 5 plus 3. So it looks like what they did is that this used to be an x, used to be 2x plus 3 from up here, and they were replacing the x with this 5 because x and 5 are equal. So replacing, let's look, when I replace something, that's called substitution also. It's just a different meaning for the word substitution, but it's still called substitution. All right, we're going to pause right there and we'll pick up in the next video.